So when you look at that, is that included in this rational form? Yeah, so that one's rational. Okay, what about square root of 4? What does that simplify to? 2, right? So be very careful. I didn't catch that as I was going around, but when you look to classify these, don't classify it based on the form of the problem. Classify it based on the value. Okay, so even though the form has that radical form, it does have a value of 2. And so is 2 considered rational or irrational? So that one would be rational. Okay. All right, now when we go to the second problem, the dot, 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 there's two different ways that we're going to represent the repetition of a pattern. Okay, dot, dot, dot depends on whether you see a pattern or not. So when you look at A, do you see a pattern here? Are there any repeating patterns in the display that they show you? No. So what that means is no pattern, so that's going to be irrational. Okay, now, what about this second example, B? Is there a repeating pattern in that display that they show you? Yeah, the pattern is that this 593, 593, 593. There's your pattern. So if it repeats, then it's going to fit that rational form. Okay. What's the other way that you can represent a repeating pattern? Okay. Yeah, the bar across the top, right? So this expression could be written 0.5287, 593 with a bar over it. Okay. It'll vary. You'll see both of these. Okay. The dot, dot, dot is easier for me to enter on the computer. So that's probably the one that you'll most likely see. So be able to identify, is there or isn't there a pattern that's being displayed? Okay. Looking at question number 3, an example of a number that would fit this pattern. Up there it looks like we have number 1. Would that work? Go to the most specific thing. Is the number 1 a natural number? Yeah. So again, any counting or ordering number would work. 1, 2, 3, 4, 5, 6, or so on. Okay. Number 4, nobody did it, so we'll just talk through it. A number that's real and irrational. So again, go to the most specific classification. What's an example of an irrational number? Okay, good. Square root of 2 works. Okay, again, any radical that doesn't simplify to an integer works, and anything that has a pi in it or an e in it would also work. Okay, number 5, a number that's a real, rational, and an integer. So again, we go to the most specific of those. Yeah, again. The what? E, we'll actually talk about E. It's a natural base. It comes up in logarithms. Okay, and it has to do with a limit of a number, like a finite regression type of number. We'll talk about it later in the year. Okay. So number 5, we have the number 1 written up there. Okay. Does that count as a number that is an integer, rational number, and a real number? Yeah. And again, we could have used negative numbers as well, but 1 works. All right, question number 6. And here, when you're looking to classify, and you guys are going to be asked to do this on quizzes and tests, and it will be one where you are asked to identify all that work. So it'll be check all of the boxes that apply, which of these is classified as, or which subset are each of these classified into. So for 3/4, you'd have to identify all the possible subsets from natural through real. So 3/4, what's the most specific classification it falls into? Rational. So when you look at the box, okay, or the chart here, the most specific one it falls into is this category. So it's going to be this one and everything that surrounds it. So the only one surrounding it is the all real numbers. So it's rational and real. You do need to include that if it falls into any of those subsets. Okay, what about negative 12/4? Again, the form of it is a rational form, but what's the value? It simplifies to negative 3. Okay, and so negative 3, what would be the most specific classification for negative 3? Integer. And so then everything that includes the integer, everything on the outside of that will also be included. So it's integer, it's also rational, which means it's also real. And again, you find the most specific one first. All right, number 7. Okay, 7 is somewhat or when you look at number 7, it looks like it has a repeating set of numbers, right? 3, 4, 3, or 3, 4, 5, 3, 4, 5, 3, 4, 5. But is there a dot, dot, dot? Is there a bar on top? No. So in this case, this isn't a repeating number. It's a terminating decimal. So based on that, the most specific classification is rational. Hey, which means also it extends out to reals. Hey, what about B? The dot, 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 is there a pattern there that repeats? No, so most specifically it is irrational, which also means it's real. Okay. All right, moving up to 8 over there. Okay. You want to pick values that fall between these two limits. Okay. And so the group picked -3/5. Is that true? Does -3/5 fall between -0.56 and -0.65? Yeah, because the value is -0.6, right? So that fits. Okay, the second number was chosen, -5.765. Okay, does that number fall within this range? Yep. And then finally, the last one was 3.6. Does 3.6 fall between 3.46 and 3.64? Yeah, so those fit as well. All right, in this example 9, which two numbers are irrational? Okay, so when you look at that, square root of 56 does not simplify into an integer. Does square root of 25 simplify to an integer? Yeah, so really this becomes 8 minus 5, which is 3. So that one is rational. And then finally, root 73 does not simplify to an integer. So the two that are irrational are A and C. And those are labeled up on the board as well. All right, and finally, placing these numbers in the correct spots. Okay, we have -0.452, or sorry, -0.462. Is that an integer? Whole number? No, so that's going to fall out here, right? So that's not even in there. You don't have to write it outside, but -0.462 is outside that Venn diagram. Hey, what about -56? Is that a whole number? No, is it an integer? Yeah, so that's going to be listed here. So it's not overlapping, it's in the integers by itself. What about 735? It's both. How about 0.326? Neither. 8,321? Both. And then 0, both. Are there any numbers that would fall in here? Is there a number that you can think of that would fall into that region? A whole number that's not an integer? No, right? Because integers or whole numbers are completely contained within integers, right? Again, if we go back to this, a whole number is completely inside this box of integers. So there's not a single number that could exist to fall into that category.